Welcome everyone to a new class on light, reflection and refraction. This is for class 10 science, chapter 10. So reflection and refraction. So we will quickly look at what is reflection, what is refraction, and then we will take some examples, and we will also look at the difference between reflection and refraction. So starting with reflection. You stand before a mirror and you see yourself in the mirror, right? So when light hits a medium, could be any surface, it can either be absorbed, could be transmitted through it, or could be reflected back. So we often actually see a combination of all these three things when we look at a certain material. The variation happens in the degree at which it absorbs, transmits, and reflects. So now we are interested in the reflection part of this possibility, and that reflection could be of two types: specular reflection and diffuse reflection. It's going to be easy to understand these two types when we look at an example. So this is an example of specular reflection. So it reflects light which arrives at a certain angle, and we see the reflection happening at the same angle. But in case of a diffuse reaction, so a marble ball, very similar to the steel ball that we saw earlier, but you don't see any building or any object on this marble stone. That's because this is a diffuse reflection. We see a broad range of angles here that it's reflected in different directions. So that's the reason why you don't see a single object being reflected off the surface. So both of them are reflection. So if you look at your mirror and say that's a reflection, this marble ball also reflects light, but it actually is a diffuse reflection. That's the difference, where anything that reflects may not be specular. Some of them could be diffuse reflection. So that is something you need to keep in mind. Could be a tricky question that can come up, where a question could be asked about an object being reflected, that you should be able to see an object at the background. Need not be. A reflection could be a diffuse reflection, wherein we don't see any object appearing on this surface, but nevertheless it is a reflection. Now let's look at refraction. So we have two medias here, material A and material B. A wave, let's take a light wave, passes through these two mediums. When it passes through material A and through to material B, you see that there is a bending. That's because the speed at which the wave or light travels is going to be different in these two materials. That causes a bending of the wave, which is a light wave in this case, that you actually would be seeing. Let's look at an example to make it much clearer. Take a bowl of water, fill it maybe up to the half wave mark, and put a pen underneath. You would see that the pen, although being very straight, appears to be bent around the contact layer, the layer where air and water meets. Why is it bent? The pen is actually not bent, but it appears to be bent. We call it apparent because it appears to be bent. But that's not the reality. We know that the real pen is not bent. You could try it out at home yourself, and you would see that the pen is not bent, but when you put it inside this bowl filled with water, it appears as though it is bent. That's because of refraction. You have two medias, air and water, and since the wave passes at different speeds through these two medias, it appears as though it is bent. So light could be bent towards or away. We will talk about that in subsequent videos, But for now, you could remember that when you pass a wave which includes light wave, through two different medias, there could be a bending towards or away. And we will talk about that later. But we'll also look at one more example to make it much more interesting. Why do you think stars twinkle? Just like the earlier example, in this case, the atmosphere has multiple layers. So the star is on the other side, you have atmosphere in between, and the atmosphere has different chemicals and molecules in its layers, and these properties keep changing every second, every minute, every hour. So when you change the medium, the apparent location of the star also changes. The light bends because of this medium. The medium itself is changing, so constantly the location of the star, you know, looks as though it is changing. It's apparently changing. It's not real location is not changing, but it appears to us as if it is changing. Just like the pen example, the stars appear to be at a different location because the medium, the atmospheric layers keep changing their properties. So this is a very good example of refraction. Refraction is the reason why you see that the stars twinkle. The location of the star keeps changing, apparent location keeps changing, and it appears as though it's twinkling. So now comes the question, what is the difference between reflection and refraction? So reflection involves a change in direction of waves when they bounce off a barrier, a material. It could be any material. We saw two different materials, a steel ball and a marble ball. Both of them have reflective properties, although different type of reflection. One was specular, the other one was diffuse. Nevertheless, both of them were reflecting the waves, light waves, when they bounced off its surface. Refraction of waves involves a change in direction when we involve two different medias. So when light passes through different medium, then we see a change in direction of light waves as they pass from one medium to another. That's the reason why we saw the pen to appear to have be bent, and similarly we saw that the stars started to twinkle when the atmospheric properties kept changing